Hi, my name is Caitlin. I am doing a tech talk on diagnostics for all. It is a low-cost, easy-to-use point-of-care diagnostic system for the developing world. It uses paper to diagnose people. So the paper is patterned and it's low cost to support development in countries that are still developing and don't have access to medical systems and hospitals. So its abbreviation is DFA, and it uses patterns of channels and wells or assays containing biological and chemical reagents to react with samples on the paper. And their paper is usually about the size of a stamp. It's very inexpensive, universally available, and compatible with biological and chemical assays. So a biological sample like blood, urine, saliva, or sweat is applied to the paper. And then the sample is sent through the channels and the assay zones to process the biochemical reaction. So when the sample comes into contact with the assay zone, it changes colors. So it makes the sample readable through the color change with a reference scale that's printed on the device. So this is how it would work. So it could be blood, it could be urine, sweat, whatever. And then so you prick the fingers if you're using blood and put the blood on the paper. Then the blood is filtered through the channels and the wells, and that's this flower pattern here is what the wells and the channels make up. And you can see the color changing has taken effect, and over on the right we can see where they can see the colors. So purple would be dangerous and blue's more normal for this first circle. So you can see they're kind of in the danger zone. So this little paper is also put through the system depending on what they're testing. And this system makes copies of these samples, and the copies analyze the reagents, and it prints out lines that help the medical professionals diagnose and read the results. So it's a nonprofit enterprise with biotechnology and device development, and they want to save lives and improve health in the developing world. They want to create low-cost, easy-to-use point-of-care diagnostics designed specifically for people in the developing world, like cities in Africa, villages, people who don't have access to normal technology, especially in the medical field. Their paper-based devices require minimal training to use, no sample preparation, and no electricity or additional equipment to process. So it's very on the go, and the whole process takes about 45 minutes to an hour. So they can easily do this in villages and where people might not have the time or the energy to go to a medical professional and wait for results. So future progress, so right now they can test for like Ebola, Zika, those kind of diseases, but they also are trying to develop a nucleic acid amplification based paper microfluid device for infant diagnosis of HIV. And they got a grant from Saving Lives at Birth to do that. They want to try to make liver functioning devices, say low cost, to say whether their liver is functioning correctly, and it can provide invaluable information to healthcare providers in rural settings and have a dramatic impact on patient care in the developing world. So that would just take from a single drop of blood, and hopefully be in about 15 minutes, they would have a result. And you can see on the side a prototype of that, where they can see the controls and the differentiating colors of the sample. There are currently no effective solutions for measuring micronutrient levels precisely and rapidly at the point of care station in the developing world. So DFA is working with a Boston area for-profit to combine their low-cost pattern paper-based diagnostics with the flexible electronics platform from Boston. So it creates a new simplified design. This will enable accurate monitoring of micronutrient levels in rural settings at low cost. They've also begun to develop a low-cost rapid diagnostic test for successful vaccination against tetanus and measles. So this will test whether they have immunity through assays, and that the vaccinations are helping and working correctly, and it will impact global efforts to control vaccine preventable diseases. So here's my sources. You can go to the DFA website. They have all information and everything, and then Google for images and looking up the website. Thank you.